Let us begin talking about the lymphatic system. The lymphatic system is not one of the most well-known systems of the body, but it has two very important roles. Its first role is to return fluids back to the blood that have been left behind in the tissues. The second role is that as that fluid is being returned, it is going to be filtered by the lymphatic system. Now, the first video that I'm recording here is only talking about the first role, which is to return that fluid back to the blood. So first of all, let's talk about the fluids that are left behind. When we look at a capillary, this is what we are calling capillary dynamics. There are two aspects of capillary dynamics: diffusion and osmosis. Okay, so in this case, just to orient you, what we're looking at here is just a small slice of a capillary. This is the arterial end of the capillary, so blood is coming through this way and it's moving through this tube. This is the venual end of the capillary, so this is where the blood would be eventually emptying into a venule. So this capillary is moving through this tissue. You can see here are the tissue cells around here. And so let's talk about diffusion real quick, because that's usually what we think about when we think about capillaries, is the movement of diffusion is high to low, the movement of substances from an area of high concentration to an area of low concentration takes no effort. So diffusion is the concept that oxygen and nutrients and hormones will leave the blood and enter into the tissues where all of those structures are low in number. And then carbon dioxide and waste products will return to the blood where those products are lower in number in the blood. So that's the concept of diffusion. And proteins will also, unfortunately, leave the blood at this point. So inside of the blood, remember, we have all those blood proteins. They're wonderful. You want to keep them in there. And unfortunately, sometimes proteins will get pushed out in the process or through diffusion. They'll simply leave the blood. And that's a bad situation. You actually want to retain those proteins in the blood. So you need a way to get them back. And it's very difficult to get them back in at the venule end of a capillary. Even though some things can re-enter, proteins don't tend to. So that's one of the very important roles of the lymphatic system. Okay, so that's the diffusion story. The next story, we call it osmosis, which is the movement of fluids, but maybe it's better served to talk about this as hydrostatic pressure. With hydrostatic pressure, the idea is that fluid will exert a pressure when pressed against a wall, and it is more likely to move through when it's exerting pressure against a wall. What we're looking at here is specifically called capillary osmotic pressure. Fluids are forced through the walls, out at the arterial end, and to a certain extent back in at the venule end. So you don't have to know all these numbers yet. We're going to talk very specific numbers when we get to the kidneys, when we get to the urinary system. But for now, I do want you to understand the concept here. There are these pressures that are exerted outward and inward, but the net pressure at the arterial end is outward, because remember that blood pressure is still quite high, and then it precipitously drops as you move through a capillary, which is important. And then the blood pressure is so low when you get to the venule end that there's actually net pressure inward at this point. So many fluids will leave at the arterial end. Some fluids will re-enter at the venule end, just because that's where the net pressures are. However, you'll notice that it's not equivalent. The pressure outward here and the pressure inward here is not the same. So not all of those fluids will actually be able to be recaptured into the blood at the venule end of the capillary. So we have fluids that are left behind. This is called interstitial fluid, IF. And up to 3 liters of fluid at any time, up to 3 liters of interstitial fluid at any time remains behind in your tissue spaces.